This is the first video for 4.5. This is 3.6 in the 6th edition. 3.5 in the 6th edition is kind of a review of the complex number system with all the imaginary numbers. If it's been a long time since you've done these, maybe you want to go back and look at that section, but we're not going to go over it in class. So in this section, we're going to talk about complex zeros of a polynomial. So remember that a complex number is one that includes or can include an I, right? The square root of -1. And we write our complex numbers in the form a plus bi, where a is a real number and b is a real number, but multiplied by that I. So we refer to a as the real part and b as the imaginary part. But it means that if b is 0, that includes all of our other numbers, all the real numbers, right? So complex numbers include real numbers. So when we say we want the complex zeros, that would be all the zeros. Whether they're imaginary or not, they are still all complex numbers. So saying that we want to find the complex numbers, the complex zeros, is a way of saying find all of them. Okay, so first of all, what does it mean to have an imaginary number as our zero? So remember that a zero is just the place where the function equals 0, right? So if we have the function f of x equals x squared plus 4, and I want to find what the zeros are, I could set it equal to 0 and solve, right? But think about what you get when you get it. I mean, sometimes we just start doing stuff and we just start solving things and going through the motions and we're not thinking about it. A 0 means that if I take the 0 that I find, which would be 2i, and I plug it in, the answer should be 0. Okay? So let's plug in 2i into this function f of x. That means I've got 2i squared plus 4. So 2 squared is 4, and I squared is -1, if you remember. So that would be -4 plus 4, and sure enough, it equals 0. Okay, that's a way of saying then that 2i is a 0. Okay, so when we get it down to a quadratic, an irreducible quadratic, right, one that cannot be factored, I can still go that extra bit, and usually it's the same as when I was finding the irrational ones. It's when I plug it into the quadratic formula, right? Or in this case, I could just solve it directly. Right? So if I had taken this and just set it equal to 0, I would have x squared equals -4. Take the square root of both sides, right? So I got x equals square root of -4. Square root of 4 is 2. Square root of -1 is I. So that's where, and I get plus or minus. So I get both of them, right? I have 2. And those would be my zeros. Now, we also talked about the fact that a 0 is the place where it crosses the x-axis, right? So how does that work? Well, remember that when we're graphing something, we're talking about real numbers, right? So when we're talking about the x-axis, we're talking about real numbers. So this is the graph for x squared plus 4, the one we just solved. And you notice that it never crosses. It never crosses the x-axis, right? So there's no x-intercept. Well, if there were an x-intercept, we wouldn't have imaginary zeros. We would have real number zeros at the real number where it crossed. The only time we get imaginary zeros is when it doesn't cross there. Okay? So we can sometimes, of course, we're not going to do quadratics very often. We're going to do higher order ones. And so we could have some things that cross and some things that don't cross. So think about what a cube looks like. Okay, so a cube might look like this, right? And I would have 3 zeros. Third degree polynomial, 3 zeros, that makes sense. Okay, well, I could also have a cube that looks like this. Okay? Oh, sorry. Only one x-intercept. Okay? So I have one real number x-intercept, so that would be one real number 0. The other two are going to be imaginary numbers, but there's always going to be 3. And sometimes they'll be the same one twice, but there will always be 3 that we can account for. All right, so that's what it would look like. Now notice with a cube, we have to have one real number. Right? Because it goes forever. We can avoid the x-axis with, this loop up here, but somewhere it's got to go down to infinity, and so it will cross. On one side or the other, it's going to cross every time with a cube. What about a 4th degree? What are the possibilities for what that would look like? Well, we could have something like this, right? And we have 1, 2, 3, 4 real zeros. Okay, but we could also have, something like this, where I have 2 real zeros, and then the other 2 would be imaginary zeros, because that other little bump, it doesn't go through, right? Or I could have them all imaginary zeros. Okay? So when we're talking about a cubic, a third root, we're pretty safe in knowing, we know that there is one real 0. But with a 4th degree polynomial, they could all be imaginary. And the only way we would be able to find that then is to have a way to factor it. Okay? So let's look how this would work. Here's a polynomial, and I want to find the zeros. Okay? So when I look at my possible rational zeros, I would have the factors of 4 over factors of 1, since there's just a 1 there. So it would be plus or minus 1, plus or minus 2, plus or minus 4. Oh, 4s are not doing well. That's a plus. Okay, so let's start trying them. 1, negative 4, 6, negative 4, and let's just try 1. How many positives do I have? 1, 2, 3, or 1, right? So there's got to be at least 1. It's 1, that'd be negative 3, negative 3, that'd be 3. That's a positive 3. And that would be 3, that'd be negative 1. Alright, so 1 doesn't work. So let's try 2. 2, negative 2, negative 4, 2, 4, 0. Okay, so 2 works. So one of my zeros is 2. Okay, and what's left here is x squared minus 2x plus 2. There's nothing that I have that can multiply together to be 2 but add up to be negative 2. So I will solve this by the quadratic formula. So that would be that x is equal to negative b, so b plus 2, plus or minus, let me fix that, plus or minus the square root, b squared would be 4 minus 4 times 1 times 2. Jeez, I don't know why this is doing this today. Over 2a. Okay, so we have 2 plus or minus the square root. This would be 8. So 4 minus 8, so that would be negative 4 over 2. And that's going to be 2 plus or minus 2i over 2. So I have, my two answers are 1 plus I and 1 minus I. Okay, those are my other two zeros. Okay. Alright, so I found that's how I find my 3 zeros. Again, once I get it down to a quadratic, I just go ahead and put it into the quadratic formula and solve for that quadratic equal to 0. We still use the rational zeros theorem to help us find the first one. And when we get it down to a quadratic, if we had a 4th degree or a 5th degree, we'd do the same thing. We would have to keep looking for zeros until we got it all the way down to a quadratic so we could plug it into the quadratic formula. Alright, here's your quiz question for 4.5a, which is 3.6 in the 6th edition. Find all the complex zeros in this polynomial. Use commas to separate the answers and do not use any spaces, and that'll help you get it right when you plug it in. Do the same thing we did on the others. Find the first one, or factor. I guess you could factor this one, but you could find the first one by finding your possible rational zeros. And then once you do the division, you find the first one, you'll have a quadratic, and so you can solve the rest of the way with the quadratic formula.